Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing? I think we were discussing about how to calculate lambda max of the following molecule using Woodward and Huffman rule. So I think whatever the required rule required for unknown system, that type of the thing we have learned, discussed yesterday. Today what we are going to discuss, we are going to solve, we are going to discuss the remaining problem of the compound. And as we know that the question is generally that calculate the lambda max of calculate the lambda max of the following compound this type of the question appear in the exam. So how do you solve? So for that, what are the points required? I already told you that there you use one short form is there, that is BEHES. So this is a 5-letter short form you can use for it. And yesterday we have, I think, solved one or two example, and we have explained what is that unknown system, how to identify that system. Now let me give one more example, that is example number 3 over here. Let's see that example number I am going to draw over here. This is one structure which I have drawn over here. So here C double bond O double bond, and one double bond is here, another double bond here, and one methyl group attached over here, another methyl attached over, and another methyl group which is attached here. So these are the attachments of that methyl group. This is the structure. So as we know that while solving such type of the problem, first of all, remember when the problem is based on UV, remember lambda max means you have to calculate the lambda max of that particular compound, particular organic compound. And for calculating as a lambda max, the things are required. These are the points required over here. First of all, identify so far, and at a T.Y.B.Sc level only two systems are there. One is a diene system and another one is a enone system. Diene system, as we know that the conjugated system, there is a carbon-carbon double bond, and that double bond must be present alternatively, and that type of the system is called as a diene system. If diene system is there, you should take only one base value. But if there is a enone system, remember the carbonyl group, and that carbonyl group must be present in the conjugation with the double bond. So that type of the system yesterday we have discussed in detail. Each and every point I have explained there. So the sum of the point which is common with while adding Homo annular system, exocyclic double bond or extended conjugation, these are the common thing. But the enone system and the diene system, they are clearly differ in their subtoturn. In a diene system we are considering as a subtoturn only whatever subtoturn around that diene system we are considering, but in a enone system, while considering as a subtoturn, we first designating or marking adjacent to the carbonyl group. You remember always designate or indicate the symbol like alpha, beta, gamma, delta, omega and so on, but that should be adjacent to that carbonyl group. Whenever there is a conjugation system, means that chromophores you consider there, don't go either that side, you have to consider only the chromone system, means conjugated system, then you can label it such as alpha, beta, gamma and so on. And depending upon that, what type of the subtoturn present on alpha, suppose that is a main difference between diene system and the enone system. You should remember this is a very prominent distinction between or differentiate between diene system and the enone system. And one can identify enone system if there is a carbonyl group, then it will be definitely the enone system. Look at here carbonyl group, as I already told you that carbonyl group is always present at the outside the ring. Look at here carbonyl group, single bond, double bond, single bond, double bond, single bond, double bond, all are in a conjugation, means all the carbon carbon double bond along with that carbonyl group, they are involved in the enone system. It is a chromophore in terms of UV spectroscopic language. It is termed as a chromophore, and as we know that as the length of chromophore goes on increasing, the wavelength also goes on increasing. Wavelength and the chromophore, they are directly proportional to each other. Directly proportional to each other means they are, if chromophore increases, lambda max increases. If it is decreases, wavelength also decreases. So that is the real meaning of directly proportional to each other. Now, first of all, can you by knowing your previous knowledge, can you tell me which type of the system present here, whether it is enone system or diene system? By observing this example, this structure or this compound carefully, you will find that this carbonyl group, it is in the conjugation, and therefore this you can mark it or you can label it, and while solving the problem, so you can write one sentence: it is an enone system. It is an enone system. And as we know that once you recognize it is a enone system, what is the next point? Next point will be base value. And as we know that if diene system is present, it has only one base value, but enone system there are 3 base values. Remember, if 6-membered ring, the carbonyl group attached to the 6-membered ring, or there is a alkyl group, then we should consider base value 215 nanometer. If you remember yesterday's structure, that Z is adjacent to that carbonyl group on one side, it is exactly opposite to the conjugated double bond, that is considered as a Z. If that carbonyl group, that Z has a hydrogen, means that aldehyde group is present, and as we know that aldehyde group is always present at the end of the carbon chain or the carbon framework, and if it is present in the conjugation, then the base value should be 207 nanometer, and if the carbonyl group is attached to 5-membered ring, then the base value for enone system should be 202 nanometer. That are the thing you must remember here. Now the base value for this. Now look at here, the carbonyl group is attached to 6-membered ring, therefore the base value for this enone system should be 215 nanometer, right? Now what is the next? If you write as a 215 nanometer, half of the work is done here. Now rest of the thing, look at here. E stand for exocyclic double bond. Is there exocyclic double bond present in this compound? And as I already explained you that, told you that if there is a ring, you can label it. So here this is a ring, this will be the B ring, right? Now one trick I already told you that while identifying exocyclic, what is the trick you should remember? You put the hand on a ring and see the outside the ring, whatever bonds are there. If you see here, this is a one bond, this is another bond, 2 single bonds are there, but here it is a double bond, and A has one outside the double bond, and therefore it is termed as a exocyclic. Remember, means A ring has one exocyclic double bond. If you put a hand on B, what do you see over here? Outside the ring, whatever bonds are present, here single bond, here single bond, here also has a single bond, here also has a single bond. Don't count, don't consider that carbonyl group. It is always outside. Don't consider. Some of the student counting this is a exocyclic. Don't do that one. So this B ring does not contain any exocyclic double bond. Remember, only A ring has one exocyclic. So you must say here there is a one exocyclic double bond. Exocyclic double bond. Exocyclic double bond. How many there? Only one. So how much to add? You should add 5 nanometer in it. Now next, A stand for as a Homo annular system. Now we already know that Homo annular system. You know the concept of Homo annular. If both the carbon-carbon double bond present in the same ring, which are conjugated to each other, that system is known as a homoannular system. If you see over here, if you observe the ring A carefully, what do you observe? Look at here, carbon-carbon double bond, single bond and double bond, both the carbon-carbon double bond present in the same ring, it fulfilling the requirement of homoannular system. According to that statement or according to this definition, it fulfilling that one, and therefore there will be a one homoannular system, and you can write homoannular system. Homoannular system is present. If homoannular system is present, as we know that how much to add, you should add 39 nanometer in it. So you add 39 nanometer, that is a homoannular system. Now look at another E is there. E means what? Here E means extended conjugation. Remember, here is a enone system, as we know that this is a enone system, and excluding the enone system, count how many double bonds there. Here 1 and 2, there are 2 extra double bond present in this compound, and therefore you can write here there are 2 extended conjugation, and here extended conjugation 2 into 30, so it becomes 60, right? 60 nanometer. And now the last point, which is very important, that is a subtoturn. As I already told you that these subtoturns are totally different from the diene system. In what sense? Here you should remember the subtoturns are alpha, beta, gamma, delta and so on. So this is a carbonyl group. Adjacent carbon atom is termed as alpha, then adjacent carbon atom beta, gamma, delta, omega, and so you consider here as a delta. That's it. That is the limit to this system. Up to the delta you can remember. So now, if now is a subtoturn, right? Substituents. Now subtoturn alpha. Find out. At alpha there is a hydrogen atom, no alkyl group. But at beta, look at here, there is one ring residue. If ring residue is there, how much to add at beta position? You should add the 12 nanometer, which is given in the chart or which is given in the table. That is a fixed value, that is a 12. Now come to this point, there is again this carbon atom having as hydrogen atom, there is a no subtoturn present at gamma position, so there is no subtoturn. Here delta hydrogen, but it is considered as a delta, so at the terminal there is a one ring residue, means you should write it down here. Delta is how much to take? There you can take as an 18 nanometer, that's it. And then you can mark here and you will get lambda max is how much? If you add here 8 and 2, 10, 9, 19, 5, 23 and 5, 28. So 28, 8 you can write here. It comes as a 2, 2, 3, 4, 4 and 6, 10, 10, 11, 12, 13, 14. Here is a 14 you can write 1, and so 348 nanometer is what we can call it as a 348 48, that is a nanometer. So that is comes over here, I think not 8, here is 8, 10, 9 and this 10, 49, 349 nanometer, that is the right answer of this. If you go on adding, if you use a calculator over here, you will end up with 349, that is a total value, means which is a lambda max comes over here. So in this way you can solve this problem systematically, then you will get the 2 mark over here. Now let me give one more example over here, that is example number 4. Let's see the structure over here. The structure will be this one. This is a structure here, double bond, and then there will be another ring joined to this. This is a one of the structure. Now observe this structure carefully and tell me what kind of the system present in this compound, whether it is a diene system or enone system. At T.Y.B.Sc level we are going to consider, we are going to study only as a 2 system. One system we already studied, it is a second system. In that second system, whether it is enone system or diene system, if you observe this structure carefully, there is a carbonyl group is present, and therefore definitely there is a possibility of presence of enone system, and that carbonyl group, whether it is in a conjugation or not, if it is in the conjugation, then and then it is considered as a enone system. If the carbonyl group is not fallen in the conjugation, it is not considered as a enone system. Please note it down. Now if you see carefully here, carbonyl group, single bond and double bond, means you can mark it. So there is a enone system is present, and while solving you can write it down. It is an enone system. It is an enone system, right? If enone systems are there, remember there are 3 base values depending upon the carbonyl group. Now if the carbonyl group attached to 6-membered ring, the base value should be considered as 215 nanometer. Most of the students making as a mistake, they are not remembering the values, because they should see the table which is given at the end of the question paper. There these values are mentioned, so they should see those values properly, then they get click in their mind and they can solve such type of the problem very correctly or the perfectly. Now let's see over here enone system. Now see the carbonyl group. Carbonyl group is attached to the 5-member ring. Now tell me what should be the base value I should take here, I should consider here. I must take the base value here. Base value should be 202 nanometer. If 5-membered ring is there, then you should take the base value is a 202 nanometer. If aldehyde group is present, then you can take it the 207 nanometer. So but here the 5-membered ring, then the base value should be 202. Now E stand for exocyclic, so label it. Is there ring present in this compound? Yes, this compound contain the ring. There are 2 rings and we label ring number A, ring number 2. Now another, while identifying exocyclic double bond, you put the hand on a ring. What do you see? What do you observe here? You can see clearly there is one exocyclic to the A ring. Don't count this carbonyl group. Now if you put a hand on B, what do you see? You will see one exocyclic double bond, means this double bond common to both rings. So you should consider two exocyclic double bond here. So therefore exocyclic double bond is how many there? 2 is there. So you can add here 10 nanometer. So 2 into 5 means 10 nanometer. Now next point you should consider, what is the next? H stand for Homo annular system, and as we know that Homo annular system is the system, the ring which contain both the double bond in the same ring. If you observe this structure carefully, you won't see any bond in the ring, and therefore there is no question of Homo annular system in this case. Now again, as a E means extended conjugation. Is this molecule have extended conjugation? No. Only enone system is there. There is no question of extra double bond in this case, and therefore there is no question of extended conjugation. No extended conjugation presence over here. Now subtoturn, and now we have to pay the attention while identifying the subtoturn, because it is a very prominent or the important one, and therefore special pay the attention toward that one. Now this is a carbonyl group, adjacent carbon atom go this side. Whenever there is a conjugation, that side you have to label, you have to indicate that alpha, beta, gamma, and so on. So look at, this is adjacent carbon atom, it is termed as alpha. Is this alpha has any subtoturn? Yes, this alpha has one ring residue, or we can call it as there is a one subtoturn. So here subtoturn you can write here subtoturns, and at alpha position one subtoturn is there. How much to consider? You should consider 10 nanometer. You should add in it. Now then adjacent carbon atom is termed as a beta. Look at the beta symbol. How many beta subtoturns are present? Look at this side one subtoturn, this side another subtoturn, means there are 2 beta subtoturns are present, and therefore here you can write as a 2 beta. 1 beta you should add 12 nanometer in it. Now is a 2, so you should add 24 nanometer in it, and that's it. And here you can write as a lambda max is equal to, go on adding, 4 and 2 is 6. Now 2, 3, 4, you can write it down here, and 2, so 246 nanometer. 246 nanometer, it is a answer for this problem. So in this way we can solve the problem based on this. I think with this let us stop today here. Remaining problem we will solve tomorrow. Thank you. Have a nice day.